All right, thanks, Mike. Hello, my name's Corey Schimpf. Like Mike said, I'm a PhD candidate in engineering education, and I'm working on this project with Dr. Joyce Main, who is an assistant professor in the department. And just to give a little background, this particular presentation is just a piece of a larger project, and what that larger project is Dr. Main actually, I guess, knows Kelly, who's the director of diversity for the center, and they were talking about doing some work related to that. And there's quite a bit of research out there actually on diversity in the computing field, but there's not a lot of papers or that sort of integrate and bring all that research together. So this particular presentation is a slice of a larger project I'm working on that's trying to go through all different research out there and sort of synthesize it and bring it into one large um, collected literature review of all the different stuff that's been found to affect whether or not different people come in and fall and continue in different computing fields. Um, this particular one, I've been working on it, and I found a lot so far on sort of the pre-college and college years. So this presentation is scoped more towards that. But the larger project will actually be looking more over the entire span pathway from very early years to later on, going out into industry or going out to an academic job. And I'll talk a little bit more about the larger project and the larger goals at the end of this. Uh, just to give an overview of kind of where this talk is going. Um, First, I'm going to talk a little bit about why is this a question looking at women and minorities in computing fields. And after going over that, I'm going to talk a little bit about very early on what are some factors that lead into an interest in computing and how that differs somewhat between different groups. And then I'll talk a little bit about the high school experience and some things that happen there, and I have some data to present on different trends and who takes different computer science related classes in the computer science AP exam. After that, I'll move more into college years and some factors that affect success in the computing fields once we get to the college years, and also look at some NSF data actually we have on college graduation for people in the computing fields. And I'll try to summarize it all together. And at the end, I'll also talk about some things. What can we do? I don't want to just present all, well, here are some things that are happening and they're barriers for entry. I also want to talk a little bit, what are some things people have done um, that have proven effective for helping groups who have difficulty getting into computing have a better chance. And then at the end, like I said, I'll talk about future directions for this project. So why look at women and minorities? This actually isn't something that's unique to computing or computing fields. This interest are looking at underrepresentation. That is, if a given population, just say women, are 51% of the U.S. population, in a lot of STEM fields, they are a much lower percent of the people pursuing those degrees, including many computing fields. So it's not something unique to computing. I am from engineering education, and this is a topic we look at a lot in engineering. Um, so it's something a lot of the STEM fields are dealing with. And there's some discussion, is this more of a matter of interest that maybe some groups are more interested than others? Certainly, interest is a factor in choosing a particular discipline, but it's not the only factor. And there's a lot of research pointing to other things that can act as barriers or make it more difficult for some groups to get involved in different STEM fields, including computing. And there's a bigger question too, if that is the case, it's not just a matter of interest. That's then something the computing field has to talk amongst itself about, whether that's okay or whether there's something people should do about it. And there are quite a few researchers who have looked at that and tried to argue for making different changes in relation to that. And the other point as to why to look into this topic is if some barriers are removed, and that means new people and new ideas will come into computing, and that can potentially expand the field, lead to new innovations. So that's another potential benefit that may come from it. So starting off looking at the very, very early years, some things that affect potentially becoming interested in computing, having a computer at home, perhaps not surprising, parents or relatives who are involved in computing, Oftentimes, a parent or relative may act as a mentor of some sort, or support a child's interest in computing. Another one actually is video games, and the way that sort of happens is if people are interested in video games, some people will then look at the mechanics behind video games. They'll get involved in things called like modding communities, which are where they modify the game. So in order to do that, you need to get behind the game to some of its code. So these are some very early on avenues through which some people get interested in computing. Um, but it differs for some groups in terms of access to this, and that's where I'm going to turn now. You may have heard somewhere, or may have not, there are discussions about toys being gendered for boys and girls. So, for instance, trucks are for boys, dolls are for girls. There are some studies that find for computers, they tend to be more casted as a boys, toys primarily for boys. And there are studies that find that parents will be more encouraging, supporting for boys' use of computers. So they'll often perhaps have like a computer in their room or more regular access to the computer. And what that means is they'll just have more time to play around with it, more chance to get experience. And it may not necessarily be intentional on the parents' part, but it does give some groups more experience with computing than others, starting at very early on. Um, this top table here was some recent data from Pew Research Center, and they just did a national survey looking at households in the United States and if there are any differences in terms of broadband access at home. So you can see up here, let me see, I've got this little arrow, where'd that go? Here we go. So you can see up here for, for white, oh, that goes over it. That's not particularly helpful. For white households, about 74% of them, as of 2013, have broadband access at home. Black households, 64, Hispanic, Latino, 53. When you add smartphones to that, so either broadband or smartphone, it actually becomes somewhat similar between the groups. Um, but there is a big question of whether or not smartphones can really account for this gap. Um, so if you have a laptop at home or a desktop and you have broadband access, that laptop or desktop can probably use a number of programs. It can use compilers. It can use different media generation programs that aren't necessarily always accessible on a smartphone. So it is a much more powerful tool. So although taking into consideration smartphones does uh, sort of bridge the gap in terms of digital access, there is a question of whether or not it's the same tool. Um, Another thing is for less affluent households, which isn't necessarily an issue of ethnicity or race, but it does sometimes cross with that. For less affluent households, computer or computer access is often shared. So that means there's less time for a young student to spend more time messing around with the computer, having a chance to experiment with it. And there are also studies, oh, and I should mention as I'm going through all this, if you look at the bottom of each of these slides, they'll have some related cited work where all these findings come from. Um, this is a point of reference. Um, so there are also findings that some households may have computer or broadband or smartphone, but they may not have all three, especially when we get into less affluent households. Um, Another thing, so gaming is sometimes an avenue into computing or getting involved in computing. Historically, if you go back some years, gaming is considered more of a male hobby. Um, in 2013, the Entertainment Software Association released a figure that as of now, about 59% of gamers, or not, 49% of gamers are women or girls. And there have been changes to the kinds of games thematically that has happened over time. Um, Although there is also an issue that maybe you have heard about, Gamergate. Kelly had mentioned this in an email. Gamergate is, and it have been a number of threats, personalized threats to individuals who are women who are in the gaming industry or involved in the gaming industry. And it is a sign of a larger trend that research is pointing to as well, that although there are increasing number of women who are gamers and increasing numbers in the industry, it's still a somewhat of a chilly environment for women. And so as a young girl who may be interested in gaming and is looking out at, hey, maybe I could use this, get involved with this, go study programming, be involved in game design, when you look out to industry and see these sort of things happening, it certainly is dissuading for young girls. Another interesting series of studies looked at African American males because it was found that African American males and Hispanics as well, Hispanic males tend to play games at the same rate as white males, but it doesn't seem to be the same avenue into computing for them. So some studies look into that in more depth, and they found that, at least for the African American males they studied, they had a sort of different play style. They tend to play socially in the sense of like having a living room and having lots of people there with them. They were more focused on competitive play and on a console. And of course, consoles have proprietary software. It's harder to get into the code behind it. A lot of the modding community is based around PC games, and the focus on competitive play and playing with others just meant they tended not to get so much involved in looking at the code behind it. Um, However, the researchers also, and this will be a point I'll talk about at the end of the study, the researchers also set up an internship for these young males to help sort of bridge this interest in video games into an interest in computing. So there is some work related around that, and I'll talk about more about that particular point at the end of the talk. So that's sort of ending sort of the early years, some things, and I guess I should take a step back and say two things. One thing is that because this is an ongoing study, it's not like I've not read through all the literature yet. So I'm highlighting some key points and key themes I found so far across a number of studies, but this isn't the total piece. There is more out there. Some groups here, are more emphasized than others. I'm just reporting on the ones I found the most research on now, but I have a large stack of papers and book chapters to read through that cover more research. Um, and the other point is the idea of talking about some of this is just to, you know, obviously societal trends, things like that, the way parents raise their children, how toys are introduced, is not something perhaps university staff or faculty or students can change, but it's good to be familiar with it for later on when these students enter our classrooms to kind of understand where they came from. So moving now on to the high school years, um, as many of you know, there was an explosion of computers and in the 90s, and that led to computers being in the classroom. And when that initially happened, there was sort of an unequal distribution of them, especially in urban schools, which tend to have more minorities. There were usually far less computers than suburban schools, which typically have fewer minorities. And there was a big policy push by state governments and different industry partners to get more computers in the classroom. And that in itself was actually fairly successful. It did substantially increase the number of computers in the classroom. However, there have also been studies that found the way computer use in classrooms when you compare like an urban classroom to a suburban classroom is quite different. For instance, in the suburban classroom, they may spend more time doing things like creating media, getting into programming, web design, that sort of stuff, where in the urban classroom they may not have as much time to do that. They may focus more on sort of computer literacy, can you use Office Word, typing, that sort of thing. One of the reasons for this is a lot of the urban schools are overpopulated and underfunded, so they have a lot of students coming in. They don't have the budget or they can't hire teachers to teach more in-depth computing classes. So an example of this, the Los Angeles example point at the bottom, a researcher, Jane Margulis, was looking at a number of high schools in the Los Angeles area, and there was one that was primarily African American, Hispanic population, and at the beginning when she started studying there, they actually did have at least one programming class, but because of budget constraints and having so many students, that professor was moved over to math, and the class was cut because there was no one left to teach it. Um, but they still found students there who were very interested in computing. So there was one student that stuck out in my mind, I remember from what Margulis wrote, and he was very interested in web design. He was a young Latino male, and he actually took their sort of introductory literacy computer class multiple times because they'd have a little segment on web design just to get as much out of it as he could. But the big point from this is that looking back to the high school years, if we look at a lot of urban schools, because of crowding and lower funding, they may not have the same opportunities to take sort of higher level computing classes to prepare them to go off to college and then pursue computing degrees then. So I say this, I want to step back and give a caveat to this particular point. Um, what I'm talking about here does not necessarily mean that that people who fit this quote unquote stereotype are bad people or they don't belong in computing relating fields. But the issue is that there is research that finds that there is a bit of a stereotype for who fits into computing fields, and a lot of women and minorities will judge themselves by that and feel that they don't belong, that there is no place for them in computing. Um, so that is where this sort of stereotypical image becomes a problem, but not because of the people themselves. So the stereotype here is that, you know, people who are in computing, who go into computing, are usually male, often white, heavily interested in computing, uh, perhaps very interested in geek culture, so gaming, sci-fi, stuff like that. Um, and there are numerous studies that find at the high school level, women minorities are aware of that stereotype and judge themselves by it. So when they do even have the opportunity, their high school has these sort of classes, they may not take it because they don't see themselves as belonging. They see, oh, that's more for other students. That's only for students who are really, really obsessively into computing. And so in that way, they don't end up taking it and don't get that sort of experience. So this is, there is an association, and perhaps you're familiar with it, the Computer Science Teaching Association, uh, I believe it's, or Teachers Association, that's what it is. Um, and they did a national sample of high schools across the United States. Um, and unfortunately, the way they asked this question was a little less useful, but it is some interesting data. So they did a sample of high schools across the United States, and here on the y-axis is the percent, oops, I gotta stop doing that, percent of classes that fall into this group. And instead of asking exact percents, like what is the representation of women or different minority groups in the class, they asked sort of a range. So the range was 20% or less on the lower end. And you can see here on the far right, there are some population averages. Women are about 51% of the population, African Americans 13, et cetera, et cetera. Um, so what these lines are showing, just start off with the bottom red line. In computer science related classes, in 2005, of this national sample, 40% of them had 20% less, had 20% or less of women. So if women make up 51% of the population, half of their representation or lower were in these classes, and that actually increased as we go from 2005 to 2013 up to closer to 60%. And if we look at the AP classes, so computer science AP classes, the number is even larger for women. So women are severely underrepresented in these sort of classes. So they're not taking them. And while interest is a factor, and undoubtedly some of these other exposure, opportunity, sort of imagery that comes from who is and who doesn't belong in computing also play a factor in it. And here in the middle we have the two lines for minority students, and they hover somewhere around 60. It does drop a little bit, but either way, they are 20% or less is lower than their population averages. So across over the half of classes, except for early on right here, um, there are very few women and less minorities in these sort of classes. Oops, here we go. Uh, So this one was an interesting one. It takes a second to explain. Basically, I'm just going to give an example to help you understand what this graphic is about. So let's say in California, I'm just throwing this number out there, it's not necessarily correct. In California, its total population of African Americans is 20%. If the number of people taking the CSAP exam was 20% African American also, then California would have a rating of 1 or 100% and would be sort of a reddish color across these maps. So this is breaking it down by different groups um, and comparing the ratio of how many of a group took the CSAP exam and what the representation was in that state. And this also came from the Computer Science Teaching Association. Unfortunately, we only have half the states, but it does give us a pretty big sample of what's going on in different states. And you can see, and I should also say these are colored relative to each other, so it's the same coloring scheme across all three graphics. And if we look at African Americans here, they never even come close to taking the CSAP exam relative at the same percent as their representation in that state. It's a little higher for Latinos here, and we see some three southern states are about at 1%. What red is about where 1% starts, or sorry, 100%. Whites, for the most part, are right at that, although there are some states here in the Midwest that are a little lower in the gray area, which is somewhere 80 to 90%. And for Asian Americans, it's quite a bit higher. Their lowest percent is 200%. So that means if in some state, let's say Wisconsin here, because it's one of the red ones, if they make up 5% of the state population, then they made up 10% of the CSAP exam takers. So what this shows is, when we get to that level, this level of college preparation in high school, students aren't, especially African Americans, Latinos, are not taking it. And again, while interest may be a factor in it, the availability at their school, the kind of images that are sent about who belongs to computing are also factors and lead to these sort of outcomes. So I'm moving on now to the college years. There was an interesting study by this researcher, Cahoon. He's done quite a bit of research about women and minorities in, well, especially with Cahoon, women in computer science. And he wanted to look at, are there differences in terms of, so now we're moving into college, we're looking at people who have gone into computing. Are there differences in across departments in terms of how students leave those departments in terms, which is normally called attrition. And so here, this green line with the little triangles is women's attrition rate. Oh, and I should say, let me take a step back. This is for Virginia in specific. So this is 23 institutions in Virginia. So it's not a national sample. However, Cahoon in the actual full paper shows that the tendencies in terms of graduation and who's getting degrees in Virginia are relatively similar to the United States. So it may not be, you may not be able to exactly extrapolate to the United States, but it's similar to trends that are going on in the United States. So this is 23 institutions within Virginia. And the green line here are women's attrition rates at these different institutions. And the line right here breaking is 0, and I'll explain that in a minute. And then the orange one is men's attrition rates. And then this blue line here is the difference between them. So it's men's attrition rates minus women's attrition rates. So if it goes very deep, like this spike right here, then that means women's attrition rate is much, much higher than men's attrition rate. So this was an important finding because it suggests that there are substantial differences between departments. So what's that mean? It means something's going on in departments that some are retaining more women and others are retaining less. So something can be done, something is being done that causes some departments to be relatively even. Like we can see over here, these attrition rates are very similar, and other departments are quite a bit different. So what are some of those things? Some of the things Cahoon found are the gender distribution of students was one effect. So if a department had more women studying computing, then it tended to have less women leaving, or it had similar rates between men and women leaving. the faculty turnover rate. So if faculty left the department in high numbers or the turnover rate was relatively high, women tended to leave the department at higher rates than men. Um, the faculty's view and approach to teaching. So if teaching was seen as more as subsidiary to research, whoever was responsible for teaching, if it was mostly seen as subsidiary research or not something um, faculty were very focused on, or whoever the instructional staff are, then the attrition rates for women tended to be higher. The gender distribution of faculty was also important. So if there were more women faculty, then attrition rates for women tended to be lower or more similar to men's attrition rates. And additionally, kind of related to the views and approach to teaching, faculty mentoring of students was also an influential factor. So although faculty are very busy, if they could spend the time to mentor students a little bit, that tended to have a big impact and um, keep women's attrition rates similar to men's attrition rates. And so some of these obviously are a bit of a chicken and egg problem. You can't perhaps affect the distribution of students, the gender distribution of students before addressing some of these other things, but some of these other things are factors that a department could change in terms of who's assigned to teaching and how teaching is done in the department, if there's any mentorship kind of programs, hiring more female faculty, and that may then have an effect on the number of women that come into the department and then stay, and that then may further, reduce the attrition rates between men and women. So coming back to this sort of stereotypical image topic again, there have been actually quite a number of studies by a group of researchers. They basically conducted a series of experiments to see how this sort of stereotypical image impacted people who were potentially interested in computing but weren't presently in computing. So these were early college students. They had not selected their major yet. And so what they found is they tried to identify through some sort of objects that were associated more with sort of the stereotypical image of someone who's very obsessed with computing and is involved in geek culture. So they've had things like sci-fi paraphernalia, video game posters, that sort of thing. I did an experiment where they had one classroom that was set up with those kind of objects, and then another classroom that was set up with neutral objects, just painting, plants, that sort of thing. And what they found for men, when they gauged their interests between these two different classroom settings, men were equally interested, showed equal interest in computing after that, regardless of the classroom. But women showed a decreased interest when exposed to the stereotypical classroom in comparison to the neutral classroom. And that happened regardless of the proportion of women. So some of these experiments had just a few women and more men. Some of these experiments had equal numbers of men and women, and some had only women. And regardless of that, there was a decrease of interest when exposed to the stereotypical classroom. Another experiment by these researchers basically had students meet a role model. This role model was actually part of the experiment. They were working with the experimenters, but they took on a different persona. They were all computing students, but some evoked more of the stereotype and said, oh yeah, computing is my life, this is the only thing I do. And others said, yes, I'm a computer science student and I have these other interests. And what that one found was, again, there was really no difference for men. They were equally interested regardless of condition, or pretty similarly interested regardless of condition. Um, but for women, the stereotype role model uh, followed by a decrease in interest, but there was no difference whether that role model was male or female. So it was really more about sort of the stereotype invoked. And then there was another similar study by the same group of researchers. In this case, they were using Second Life, so it was a virtual classroom, similar to the first study in terms of having a classroom environment, either with stereotypical objects or not, having more neutral objects. And again, they found for men there was largely no difference, and for women, the stereotypical environment led to a decrease in interest. But in this one, they also checked perceptions of academic success. So they asked, if you were to take this sort of class, do you think you'd be successful? And in the stereotypical environment, they had significantly lower perceptions of academic success compared to the neutral environment. So here, coming closer to the end here, so now we've talked a lot about different things that affect, well, early on interest with computing, some things that happen in high school and whether or not students may take um, different classes, computing related classes, and then things that happen at the collegiate level. And what do we see? This is NSF data here. So what do we see at the end of it? Who, graduates. This is with computer sciences. Unfortunately, it's not really well split out, like what exactly falls under computer sciences. They don't break computing down into any smaller categories, unfortunately. But this is the only computing data they have. And so what we find is, this is about 20 years, well, not quite 20 years of data. Looking back to 1994 up to 2012, the red little triangles or orangish triangles here are men, and they are predominantly the graduates of, these are bachelor's degrees here, of computing fields. And we can see sort of in the late 90s, there was a spike for both men and women, a little bit bigger for men, and then the number of degrees went down starting in the mid-ish 2000s, but it started to go back up. But, again, is this a factor of interest? Sure. Obviously, there's a factor of interest, but there are lots of other processes going on in terms of early exposure, support of that exposure, the kind of imagery that's sent about who does and doesn't belong in computing, um, the departmental, kind of the departmental dynamics of the particular department someone may go into that affect that, and high school dynamics in terms of what kind of stuff is available for different students. So this is a more detailed graphic of the last one. It breaks it down not only by gender, but also by racial ethnic group. This top line up here is white men, and their numbers of graduate uh, people who got bachelor's degree in computer sciences related fields. So the highest group is white men. These little Z's down here are white women. And the next largest group, these little arrows pointing off to the right, are Asian men. And then we have this huge sort of lump of groups right here. This is black men, black women, Asian women, and one other group, Hispanic men. And so again, we see that one group tends to get most of the degrees, and while interest is a factor, there are other things going on that lead to this, and it um, suggests, all the other research suggests that this isn't likely just to be a factor of interest, that we wouldn't get this kind of distribution if it were simply a matter of interest. We might see a different sort of distribution of who ends up with degrees at the end of a bachelor's anyways. So just to sort of summarize some of the stuff I've been talking about, early supported exposure to computers is often an inroad to computing, but that sort of exposure varies quite a bit by group, by household access, things like that. High school resources, the kind of resources a high school has, sort of the images of who belongs, doesn't belong to computing, um, affects taking computing classes in high school and preparation for then pursuing that at a collegiate level. Um, Attrition rates vary quite a bit by different departments, which is, in a way, it's a good thing because it suggests there are things people can do to decrease that, as Cahoon found. And at the end, we see the highest number of graduates are males, whites, including white women, and Asians, especially Asian men. But I don't want to end this all on gloom and doom. I did say that there were some things people have done before, some different interventions people have done to affect this. So I do want to go over a few examples of those. These are just a few examples. There's tons of them out there. But one example is some researchers use Flash and action scripts in Flash to expose students to computing. So going off the assumption that these students maybe had less experience with computing, they weren't coming in with like a hardcore programming background. They use Flash as an easier road to, get into media generation, do some scripting with the action script. And what they found was when they incorporated this into their computing class at some schools, they saw an increase in the number of students signing up. Um, Although the percent of women is still small, it was an increase for that school to be at 17%, and the increase for minorities was quite a bit too, up to almost 50%. Um, Another one, what I was talking about earlier, the internship for African American males, it was called Glitch, and basically what this did, it was an NSF-funded project, and they set up an internship working with industry partners who were different game developers, and they basically hired the students on as interns. Um, the researchers did, and had them sort of debug games, and this gave them an opportunity to sort of connect their interest in video games into possible computing interests. And as a result of one of their most recent groups who went through this project, and I should note that these students were primarily from a poorer community, so it's not necessarily a given that they've actually would have pursued a higher education degree. But 21 of the 25 participants went on to go get higher education degrees to pursue them, and 16 of them went to pursue some sort of computing field. Some were more programming oriented, some were more towards media generation, web design, that sort of stuff. Another big one is Carnegie Mellon made quite a few changes. They had a large study sort of tracking, excuse me, uh, progress of different students through their computer science degree, and they ended up making a bunch of institutional changes, some of which included having graduate students act as mentors for undergraduate students, having peer tutors for particularly challenging classes. So some of the what are normally called like weeding classes are often difficult a milestone for advancing in the degree, having peers who are a little more advanced help them understand some of the key concepts from that. And another thing was an addition of interdisciplinary sort of team design based classes. And so some of the reasoning behind this was um, they found in their study and other studies have found some women who go into computing are not necessarily interested in just studying computing and getting real in-depth understanding of computers as technical objects, but they want to take that understanding and apply it to some other field. So doing these sort of interdisciplinary team design projects was an opportunity to take what they've learned in, computer science at Carnegie Mellon and apply it to something else, like medical research or something like that. Um, and so with these changes and some other ones that Carnegie Mellon made, oh, I don't know why this thing's moving. Sorry about that. So with those changes, they saw a 35% increase in women's enrollment over the course of 5 years at Carnegie Mellon. So it was a pretty substantial change. Um, so things can be done, and there are things out there that people are doing, and I mean, part of my continuing work here will be identifying more of these. But this kind of gives a brief overview of some of the stuff I found and some of the things that affect, going into computing, and what affects choices to continue on with computing. Um, so my last slide here is really more what's the rest of this project look like. Um, the full paper will try to look more at the complete pathway from the early years, which we started on, all the way into industry or academia, whatever, both of them actually, the people may end up going into. Um, Here, some coverage on some groups was less than others, and that's just a factor of what I've been able to find so far, but there is a lot more out there that I'm working my way through. Um, a lot of, you saw here was a lot of computer science, computer relating fields. I do want to get more on ECE in specific and include that as part of the larger package paper that we're working on. And another thing is within engineering education, one of our researchers here has this large-scale database called Midfield, which is great. It has a population level, so the entire school level data on students' pathways to different degrees, and that includes different computer-related fields. So I'm going to be looking at that to sort of see trends in terms of when students enter, when students leave, and that sort of thing, and trying to understand the dynamics of when students switch in, switch out. But that is what I'll be working on, and that is the bulk of my presentation here. I've already talked for 40 some minutes, so I'm going to end here and take any questions. Thank you very much for your time.